Sketching reciprocal trig functions. This is sketching the graphs of cosecant, which is 1 over sine, secant, which is 1 over cos, and cotangent, which is 1 over tan. Alright, so let's look at this example. Sketch the graph of y equals 2 cosecant of 2x minus pi over 3, blah blah, over this domain. Okay, first thing you've got to remember how to sketch the original trig function. Okay, it's gonna help you to sketch this first. Okay, so the cosecant is 1 over the sine. Okay, so let's sketch the sine function. So some of the things we need to know there. Okay, the amplitude of that one is 2. The vertical shift is 3. So that gives us the max and min of 3 plus 2, 3 minus 2, so that is 5 and 1. What else do we got here? We've got the period. Period is 2 pi over b, that is b, so 2 pi over 2, which is pi. Period is pi, so this is negative 2 pi to 2 pi. We're sketching 4 periods. And that last minus pi over 3, that's to do with our our horizontal shift. This is a minus, which means it's going which way, right or left? It is going negative, means it's going to the right. And it's going to the right c over b, which is pi over 3 over 2. Okay, c is pi over 3, so that's pi over 3 over 2 looks better. Okay, which is pi over 6. Okay, so that's my horizontal shift, pi over 6 that way. So let's sketch this thing. We know that we're gonna go hit a maximum at 5. We're gonna have our middle at 3. We're gonna hit a bottom at 1. And there it is at x. Ooh, we've got to go to the left also, don't we? Because we're going to minus 2 pi. Minus 2 pi. So that's minus pi. Pi. 2 pi. This one's a little bit tricky because we've got to get this shift. It's going to screw everything up a bit. Anyway, let me put in some guidelines here. So there's the middle. There's the top. There's the bottom. Yeah. Okay, let's see. Well, let's first look at our basic curve before we do this horizontal shift here. Makes things a little bit tricky. Let's just quickly sketch what it looks like before we do that shift. Okay, it's a sine curve. We're doing a sine curve, so it starts in the middle. It's going to start here, and our period is pi, so it's going to do one cycle and get back to pi, and then another cycle here. So it's going to hit at these points. Okay, it's also we split our period into 4. If you remember, there's 1. Okay, split it into 4, and it hits the maximum. It goes up to the maximum, back to the middle, down to the minimum, back to the middle, and so on. Okay, we'll split this into 4, to the maximum, to the middle, to the bottom, and so on. Okay, so split this into 4, maximum, middle, bottom. Okay, split this into 4 pieces. This one we go to the maximum, minimum, bottom. Okay, so we'll just dot this out. And this is before we've done our shift. Oh, I picked a hard one. This example. Anyway, this shift to the right, pi over 6. Let me just do this in a different color now. So that's pi over 4. Pi over 6 is going to be about 2/3 of the way through each of these. So this is going to be 2, this is going to be here. Oops. Okay, every point is shifting to the right, pi over 6. Okay, pi over 6 is, I believe, 2/3 of that pi over 4 interval. Okay. So that means I'm going 2/3 of the way over. So 2/3, 2/3-ish. Each of these points is over. Okay. Whoop. No, that's wrong. Okay, so we can now join these up. Move this one over. 2/3. Okay, and this one goes down a bit there. Not the best drawing, but you get the idea. Now the funny thing is, that's the sine curve. We still haven't done the secant curve. Let's just have a look in the calculator. Okay, sharing the calculator. I'm gonna do. Okay, here is. Oh, this one's slightly different anyway. It's 0.5. It's still cosecant 2x minus pi over 3 plus 1. Anyway, as for cosecant in the calculator, I just did it divide by sine. That's the same as cosecant. And here what you get is you get your sine curve in the middle there, and this is the cosecant, because cosecant is 1 over sine, and sometimes sine is equal to 0. So when you do 1 over 0, you get infinity. So when this hits 1, well, 1 over 1 is 1. So the maximum and the minimum, it stays the same. But everywhere else, as sine gets smaller, 1 over that sine gets bigger. So, and it hits its maximum at these points here, like here, when the sine is 0, it goes up. So it's going to go up like that, and it's going to get closer and closer to this line, and it's going to get, if there was another imaginary line there, it's going to get closer and closer to that line. So on. It's going to go this line from the 0. When I say the 0, what I'm saying is the middle of the sine curve. That's where sine was 0 before we shifted it up. Okay, so those 0 points, the vertical lines, make what we call asymptotes, okay, which are lines that help you to sketch. They show where the function gets closer and closer to, but they never actually touches these lines. Okay, so here's another asymptote here. This curve is going to go like that, and so on. So, you know, if you can just sketch something like that, okay. That is how you sketch a, what do you call it? Inverse sine function. Okay, so if you're doing secant, it's just the same. You just do the draw a cosine curve and then draw these weird things. And just here's a nice, neat looking one from the textbook here. And that one doesn't have a vertical shift, but the same sort of thing. Okay, you're just drawing these sort of U shape, one up that way and one upside down. Okay, at each of the high points or the low points, basically what you do. So there's There's another one that has the vertical shift. So that's the secant, so there's the u's, the upside down u's, okay? The last one, I haven't shown you this, but let's see. We've got tangent function is the red one. So the red is y plus tan x. Okay, so that's what tan function looks like. Because tan is sine over cos. Sometimes cos is 0. So you end up with something over 0, which gives you, it goes up to infinity. Okay, and then down to a negative infinity. And if you do, so the blue is cotangent, so that's 1 over. Just cot x. So at these points here, tangent is equal to 1, so cotangent is equal to 1. Okay, so they're equal at that point. As you go this side over here, tangent is more than 1. So when you do 1 over that, it becomes less than 1 and it gets smaller. Okay, and then when it hits, for example, over here, let's see. Yeah, when tangent is 0, cotangent is 1 over 0, which is either positive infinity or down the bottom here, negative infinity. Okay, depends if you're just slightly to the left of 0 or slightly to the right. Alright, that is it.